Sometimes when we're working to verify identities, it's not quite easy to turn one side into the other. If that's the case, then another approach might be to work from each side separately and turn them into a common goal. So that's the way we're going to approach this identity. I'm going to start over here on the right hand side because I noticed in the numerator that I have three terms, I have a squared term, and I can factor this, so I recognize that idea. I'm going to rewrite this so that my leading term is the squared term because I'm used to seeing it that way. So I'm going to let this look like cosine squared alpha minus 2 cosine alpha plus 1 all over negative sine squared alpha. So if I factor the numerator, it would factor into cosine minus 1 cosine minus 1. Okay, the denominator is going to, so I have cosines in the numerator, and I think that I want to try to turn everything into cosines because I recognize that sine squared alpha is can be rewritten using the Pythagorean identities. So off to the side over here, I think I'm going to kind of look at that for just a second. Remember, sine squared plus cosine squared equals 1 is the Pythagorean identity, and if I solved that for sine squared, I would have sine squared equals 1 minus cosine squared. So I could replace sine squared with 1 minus cosine squared in the denominator. So we have a negative here, 1 minus cosine squared in the denominator. I'm going to go ahead and distribute this negative sign on the outside and rewrite this so that it looks like cosine minus 1 in the numerator, cosine minus 1 all over. The denominator says cosine squared minus 1 when I distribute the negative sign inside. So again, I am looking at the denominator and I think I can factor that, so that's how I'm going to do this. So I say cosine alpha minus 1, cosine minus 1, denominator becomes plus 1, and cosine alpha minus 1. Since I have it broken down like this, I look at it and I want to cancel my like terms. So you can see that I have cosine alpha minus 1 in both the numerator and the denominator. So this leaves me with cosine alpha minus 1 in the numerator and cosine alpha minus 1 in the denominator. And I think that that's probably as far as I can go. So this is what I want to try to turn now the left hand side into. So I'm going to see if I can take the left hand side and turn it into this right here. So we're going to go back up and start thinking, how am I going to get the left hand side to be cosine plus 1 and cosine minus 1? So one thing to do is to look here, and I'm going to rewrite this all in terms of cosine and sine. So cotangent becomes cosine over sine, and cosecant is 1 over sine. That's the numerator, and then I rewrite the denominator. Again, cosine over sine plus 1 over sine. Now we know from combining fractions that I can rewrite the numerator and then again the denominator as a single fraction up here. So this looks like cosine alpha minus 1 all over sine divided by cosine alpha plus 1 over sine. That's pretty close to what I eventually want to get this turned into, but I have these sign in the denominator in each of these two denominators that are causing me trouble. So what I'm going to do is I'm going to multiply both the numerator and the denominator by this right here. So if I multiply here, oops, that's alpha, and here by sine alpha, then this sign cancels with that denominator, this sign cancels with that denominator, and it just leaves me with cosine alpha plus 1, cosine alpha minus 1 in the numerator, all over cosine alpha plus 1, which I wish somebody was here to tell me to catch that, but this should have been a plus 1 on this other side. So I could see that I had a kind of an error over here because these were almost exactly the same, and I went back, saw where to fix it from, and since I have turned both of these sides into the same thing, then that is another approach to being able to verify an identity. Okay, so let's kind of summarize what it is that we've done. The first thing that you want to do is when you're looking at verifying identities, you need to make sure that you understand and that you are very familiar with the list of identities that were given in a previous video. So far we know Pythagorean identities, reciprocal, negative angle, and quotient identities. Become very, very familiar with them and understand that there's more than one way to write those identities. Another thing to keep in mind is we want to try to rewrite the more complicated side so that it looks like the simpler side, or in other words, turn the really hard side into the easier side. That's an approach that you want to take. Another idea here is if you don't know where to go, maybe I want to take my stuff and go through sine and cosine. Maybe I want to take my terms and turn everything into sine and cosine and see how far that gets me. We don't want to forget about factoring, right? If I have a trinomial right here, then I can factor that into sine x plus 1 quantity squared like we just did in this last example. So remembering our factoring rules is really key to this as well. Okay. And then, combining fractions in one term. Or being able to add or subtract fractions in this particular case. If I wanted to add these two fractions, how do I add them with a common denominator and then rewrite them? Also, we want to see about substitution, okay? Keeping in mind that we're not changing maybe the Pythagorean identity, but we are just really rewriting what we want to try to look for. Okay, so here are some tips that you want to try to go look at, and really, as frustrating as verifying identities can be, it really just comes with practice, and it tends to become a little bit easier as you've practiced a whole lot more.